Oh yeah, thank you very much. Well, I'm so excited to be here presenting you our technology, and I was fascinating hearing all the speeches. So interesting. Let me introduce myself. I'm working at Mailer Group at the startup for Tarantool. I'm actually head of research laboratory and the CPO this new product HTAP based database. I'm working in distributed databases for 7 years, and well, today I'd like to introduce you to what Tarantool is in 5 minutes. I suppose it's very difficult, as Tarantool is some kind of Lego for creating databases. I'd like to talk about a little bit about what HTAP is for our perspective, and then I'd like to introduce some challenges we have faced with developing a HTTP database, and talk about some future work. What comes to mind if we hear a database called Tarantool? Tarantool. No way. It's not a spider or something like that. Yeah, it's a ACID compliant database which store all the data in memory. It have hybrid model, support both tables, documents, has secondary indices, compound indices of different type, B-tree, R-tree partial indices, hash indices, and so on. When we call in memory, it does mean that we can lose some data. We use write-ahead logging, snapshotting, synchronous and asynchronous replication, and of course we use sharding, for to utilize all the cores of machine and to have an ability of horizontal scaling. And last but not last, we have an application server on board, and we used LuaJIT and Lua for writing some code inside, but now we're using Rust and WebAssembly. Some random facts. Well, top clusters in Russia, for instance, one telecom operator uses Tarantool in charging, billing, storing profiles of users, collecting from different sources. Yeah, it's such an enormous amount of data in operating memory. I'm curious why we're doing that, but if you'd like to, if you'd like to dive into, you can realize that there are some reasons to do that, as all the users can do everything. I mean, we need random access to every portion of data about each user, about its history, and so on and so on. So yeah, that's amazing for me. That's not the case we are developed for. Anyway, real-time advertisement system, top one in Russia, uses Tarantool, and it's handle throughput 10 millions of requests per second, including updates, including inserts, including selects, and so on. So we need to show banner, make some bidding process in several milliseconds. So that's why it's using here. So and a lot of things. So Tarantool established 10 years before, like a technology inside the big company, and we together with our colleagues, with our team, bring it to the market as an open source project, and both, we have some kind of enterprise stuff here. So anyway, we know about more than 1,000 installations, a lot of nodes, it's a sort of marketing thing, but it's really Tarantool can handle 1 million requests per second on a single CPU core via one thread. So let's dive into some details because it's very important to understand what we're building using DataFusion. So Tarantool has one single transaction thread to manipulate all the data. It uses slab allocator and some kind of arena for storing data, storing indices. It has an event loop and with fibers, with cooperative multitasking, and as I already said, that we use write-ahead logging. Actually, for us, it's a kind of constructor, it's a Lego for inspired database makers. But actually, we've built a lot of types of databases, for instance, graph databases, vector search databases using this technology. So when you have indexes, you have allocators, when you have cooperative multitasking runtime, you can write your code using Rust or using Clo or everything else. Anyway, now I'd like to discuss what HTTP is. Well, when talking about HTTP, I think we're talking about two different approaches. The first one is to use one tool for two purposes, for two workloads. For instance, OLTP workload using row-based engine, regular tables, or OLAP workload for using columnar tables, and sort of maybe change the data capture or queues or ETLs or something like that for syncing all the data. Well, as the first approach. The second approach is to I call it hybrid approach. So, or composite, when you like to perform analytical queries in real time on the most live and most recent data with strong consistency, no dirty reads, read your writes, etc. So, this approach differs from the first one, since Tarantool is a member database, so we've chosen the second one, as we experienced the strong the strong market demand on that. So, so let's start. Let's consider we're trying to invent something, to invent HTTP-based database. So we need to bring some tables, some metadata storage maybe inside the database, some columnar tables. Of course, we need to know everything about schema. And the key thing is, we'd like to make joins between regular tables and columnar ones, but it's a tricky thing as we need to decompose all the query into maybe some queries, some subtrees of query, and use row-based SQL. We use our own virtual machine-based SQL engine inspired by SQLite. We use DataFusion for extracting subtree and delegating it for making queries over regular tables. And of course, we use DataFusion not only as a planning system, but we do execute all the queries over the columnar tables. But you can say, it's very similar to the first approach. So where's the difference? Before I dive into the difference and some benchmarks and so on, I'd like to say that we try to choose several the one protocol we go with, and we've chosen actually several protocols, PGWire for one client in order to smoothly interact with frameworks which uses Postgres. We implement flight SQL for column-based protocol and so on. We use DataFusion as some kind of glue for manipulating not only with schema yeah, we use it actually for an updating of data, writing data, and so on. Let's dive into what columnar table is, because we introduce an approach when we can take advantage of columnar processing with updates of single rows, random. We guarantee random access, and we can guarantee single inserts not only to the end of the table. So actually, our columnar engine is a sort of composite engine managing 4 layers, 4 individual engines. Let's discuss. The first is only a row-based buffer. It stores the most recent data. We use some sort of LSM approach here, so we can consider it as maybe as a cache of data, and we store only 1,000 or more items here. So the next level is BPS vector structure. BPS vector is a very complicated structure, but we can simplify it to BPS tree, which stores all the data in the leaves with small buffers. This allows us to make an update, but since all the data in memory and this structure is CPU cache friendly, so we can achieve 1 billion scans of a single column per second per thread. I think that it's good enough for our purposes, but it's a little bit well, consumptive because we need store all the data in memory, and we'd like to compress it. We'd like to have some kind of encoder, so why the third layer comes in. So we are it's a columnar-based storage in memory, but it uses compression, LZ4 compression, and encoding in order to be in order to utilize less memory than arrow buffers with data. So there's a mistake because it's because this engine, this approach can achieve 2 billion of scans per second on partially compressed data. So we split the data using some heuristics. We compress only the data from specific threshold. And we use Parquet files on S3 or SSD as a mutable archive. So in order to have an ability to perform queries against the cold data. So this approach allows us to handle workload when we have changing data, but we like to take into consideration all the changes what are going. So in that, like to introduce you one example, we start developing this kind of engine database 1 year before with DataFusion of, I think, of version 31. So our researchers start with strong demand. One client wanted to replace their anti-fraud system, and they faced with unsolvable task because their system had 3 kilos of columns, 10 billions of rows, and at the time when each transaction very close to be saved into the storage, a lot of rules should be computed. So one rule is an aggregate function over the secondary index of the columnar data. So I think that a half of 1,000 rules should be run simultaneously before transaction saved. The problem is they had some SLA because of central bank requirements. So they need to do this in 10 milliseconds. So it's a very, very difficult task to do that. Here, DataFusion helps us. So we implemented a columnar in-memory engine that supports updates because this workload also uses to update recent transactions. For instance, because, for instance, a transaction of payment consists of a smaller transaction, and the next transaction may update the previous one. And also, the results of compute rules should be written as well into the transaction. It is for making decisions. So that's why something very performant with an ability to do full scans over the data is needed for this particular case. Yeah, and let's talk about challenges. We thought that it takes us only 20 minutes, but as you can see, there are a lot of problems here. And let's start with white tables. White tables is an issue for DataFusion, and we are faced with very slow planning, which are quadratically. So I mean that which have complexity O n squared from the number of columns. It was a problem. So our case needed to implement secondary indexes, both for data which are very like to be monotonously incrementing, or but we had to implement an index, something like burn index for such data. Also, because we have our own schema, virtual schema, and different physical layouts for storing data, it was tricky to manage the schema of database, and we used synchronous replication of specific tables which stores all the information about schema. Updates and multi-version control, especially when we are using a multi-threaded runtime of DataFusion, Docker runtime, and we bring it into one threaded apartment of Tarantool when we're talking about only one shard. So it's a problem because we need to have an access to all the data holding by one thread. So we implemented read views, and because our search trees has their own translation of physical addresses to logical ones. So data, so pointers are 64, use 64 addressing, but because we are using slab allocator, our addressing allow us to use only inside 32 numbers. And because we use virtual addressing, so we can make for some threads who are which are trying to read data, make some kind of snapshot for reading, but with no overhead at all. What? And the last thing I think that is I'm considering it as a problem of joining when we are trying to join columnar-based table, column table, and with row-based one, using default DataFusion approach, we need to build index on each request. But obviously, row-based table already contains index, so it's better to use it instead of streaming that table. And we worked around this by introducing dictionaries like in ClickHouse. So when we can resolve, for instance, by some user ID in the event table, we can resolve it by ID. So just using user-defined function. For instance, get dictionary value, column name, table name, and the column expression to retrieve it. So, but I think that we need to work together on joining interface in DataFusion. Well, and I'd like to notice that DataFusion on modern hardware have some performance issues, especially when we trying to utilize all the cores of modern servers. So we benched it, and we realized it's better to use NUMA nodes and on each NUMA node run separate process of DataFusion with its own MIMO allocator, which are working on that portion of memory, which allows DataFusion scale horizontally very likely as a linear scaling. So let's talk about some points of future development. We're working on update, and we already have LSM-based engine called Vinyl. So we are have some prototypes. So in the very close to introduce updates and cold storage, and this allows us to not to consider Parquet file only as archive. Another thing is cross-shard transaction, since we have sharding, so and we support SQL, so we need to guarantee saving all the data. And we have two-phase commit and in accord options, and we are still researching which one is better. Another thing, and fascinating that community is working on that. So we'd like to introduce WebAssembly not only for user-defined function in DataFusion, but for user-defined models in the database. And I think that's it's a good idea to run AI models using WebAssembly. So WebAssembly offers to run models, and we can take advantage of running models on the most hot data, columnar and row-based inside the database. So I think that we will have some progress this year. And of course, for feature join for column-based and row-based tables. So we need to work here a little bit. So thank you.